Hello everyone, welcome to Elevare. This is Fahim and today we'll be solving the most recent paper from Edexcel IAL Chemistry Unit 2 that is from October 2025. So without wasting any more time, let's just solve this paper. So in the first question it says that what is the color of the solution forms when iodine dissolves in hydrocarbon. So the thing is that when iodine dissolves in an organic layer, the color that it forms is going to be purple. So you should be having this memorized by now, okay? So the answer should be C. Moving on to question 2. Which row shows the correct trends down group 2? Okay, so down the group, reactivity is going to increase, solubility of the hydroxide increases, and solubility of the sulfates decreases. So you should be having this memorized as well. Solubility of the hydroxide and solubility of the sulfates. So down group 2, solubility of the sulfates increases, and solubility of the hydroxide increases down the group, and for sulfate the solubility decreases down the group. Okay, so the answer should be A. So in question 3 it says that the gas nitrogen dioxide exists in equilibrium with another gas. Okay, so dinitrogen tetroxide. So this is for nitrogen dioxide and this is for N2O4. Now nitrogen dioxide is brown in color and on the other hand this gas is colorless. What happens to the color of the equilibrium when a catalyst is added? So when you add a catalyst, nothing change. There is no impact on the equilibrium position. So the answer is going to be D. Moving on. Which isomer has the lowest boiling temperature? Okay. So first of all, check off the ones that have greater number of carbon. Pentane, not at all. Pentane, not at all. Heptane, not at all. So over here we have butane. It means that it has lower number of carbons, and as it has lower number of carbon, and it also has on the other hand more branches than these two. Okay. So the answer should be this one, okay? C. Because first of all, it has lower number of carbons, which means that since it has lower number of carbons, butane, okay? Since it has lower number of carbons, it has lower number of electrons as well, and hence as a result, then dispersion force decreases. First reason would be this. If we were to make this easier, okay, for you, okay, and also apart from that there are more branching, since as the branching increases, just see a thing, see, so suppose if this is a branching, right, this is the same molecule and over here we have our branching as well. As the branching increases, the point of contact decreases, or the surface area decreases, and hence the boiling point decreases as well, because the London dispersion force decreases with increased branching, okay. Moving on. So the next question says that sodium chloride dissolved in water, okay? Which diagram shows the arrangement of water molecules around a sodium ion? Okay, so the thing is that when you dissolve a molecule, when you dissolve sodium chloride, when you dissolve this ionic compound sodium chloride in water, respective ions form Na plus and Cl minus, okay? Now the thing is that water, on the other hand, is a polar molecule, right? So oxygen would be having a del minus charge, the negative dipole, and the hydrogen would be having a positive dipole, okay? Because oxygen is more electronegative than hydrogen and be pulling this bonding pair of electrons towards itself. Okay, so if this is the scenario, then this should be the answer. B should be the answer because this is the ion and these are the negative dipoles of oxygen that surrounds the positive ion, and on the other hand this is the chloride ion and these are the positive dipoles of the hydrogen that surrounds the chloride ion, okay, because negative is obviously going to attract positive, so the answer should be B. So moving on to the next question. What is the name of the attraction between water molecules and sodium ions and chloride ions? So what is the name of this attraction? So what I could see over here is that this is a permanent dipole, del minus del plus, okay, del minus del plus. These are permanent dipoles and water is a polar molecule. On the other hand, this is an ion, right, cation and an anion. So this is going to be an ion permanent dipole interaction. So the answer is going to be D, not A, not B, not C. Okay, moving on. Which line on the sketch graph best shows the trend in boiling temperatures for the hydrates? Hydrates means nothing but H2 joined to something, okay? So period 2, 3, 4, 5. Now let me just show you something. They are basically doing nothing but trying to confuse you with this period 2, 3, 4, 5 thing, okay? So this is what they are. This is what period 1, period 2, period 3, period 4. What they are doing is that they are representing these elements of group 6 in a different way to confuse you, okay? But you are not to get confused, okay? So yeah, they're doing nothing but trying to confuse you off, right? It shows that which which shows the trend in boiling temperature for these group 6 elements, okay? So this is going to be H2O, this is going to be H2S, this is going to be H2SC selenium, this is going to be H2P selenium, right? Group 2, 3, 4, 5. Now the thing is that water molecule would be having an unexpectedly higher boiling temperature. Why is that? Because they can form hydrogen bonds, first of all, which is the strongest intermolecular force of attraction that could exist, and it requires a higher temperature to break it down, okay? Now the thing is that also down the group, the boiling temperature is going to increase. Why is that? Because the number of electron increases, and as a result, London dispersion force increases as well. So it also requires more temperature to break it down, okay? Hence, what we could see is that from the gap, lower and then increases, lower and then increases. Not at all, not at all. It should be hydrogen bond should be having some respect, you could say. And P, it decreases on this end. No, this doesn't fit the overall pattern, first of all. What should be the answer is that Q should be the answer, because hydrogen bond, water, right? It should be having an unexpectedly higher temperature, higher initial temperature, and then gradually down the group it should increase, okay? So the answer should be Q. So the Q over here should be our answer, okay? Moving on to question number 7. A mixture contains 36 gram of water and 46 gram of ethanol. What is the approximate percentage of water in the mixture by moles? Okay. So first of all, find the moles of water, because they're basically trying to say to figure out the percentage of water by moles. You first of all have to percentage of the water. You first of all have to figure out the percentage of the water. Uh, So no, sorry. So first of all, what you have to do is you have to figure out the moles, right? You have to figure out the percentage of water by moles. What you're going to do is, the mass divided by the MRA. The mass for ethanol, C2H5OH. Figure out the MR from here, and you divide this mass by this MR. You would have the moles of this, right? So then what you're going to do is MR of water divided by total MR of water plus ethanol times 100, okay? And if you do this, you should be getting an answer. And the working should look something like this. Number of moles of water, number of moles of ethanol, percentage of water, moles of water divided by total moles times 100. So this should be giving you 66.67%. So this is approximately 67%. So A should be our answer to this question. Okay, moving on. Hydrogen peroxide decomposes as shown. Okay. When you heat this, it decomposes to form this and this. 20 centimeter cube of this concentration of hydrogen peroxide solution completely decomposes at room temperature and pressure. What is the volume of oxygen that is being produced? First of all, the thing is that this is aqueous solution and you have volume and concentration, so you could easily figure out the number of moles. While figuring out the number of moles, make sure that the volume is in dm cube, because our concentration on the other hand is in dm cube. Once you have this, you're going to compare the molar ratios and they're reacting in a 2:1 ratio, okay? Which means that 2 mole of water, H2O2, forms 1 mole of oxygen. So 1 mole would be forming 1 by 2 oxygen. Therefore, X mole would be forming 1 by 2 times X mole of oxygen. So this should be the mole of oxygen. And once you have the mole of oxygen and this is a gas, what you could do is number of moles equals to volume by molar volume. This is 24. Okay, they have given in the question. You know the number of moles. You make volume the subject and multiply these two to figure out the answer. Okay, so this is what I've done over here. See, figure out the number of moles, figure out the number of moles of oxygen, and then what I did is number of moles of oxygen equals to volume by molar volume. This is the moles of oxygen. I know the molar volume 24. I make volume the subject, and my answer is 0.48 dm cube. Okay, so the answer should be C from here. Moving on, just a moment, guys. But1 in binds in oxygen in a closed system. Okay, in a closed system, what volume of gas remains in the system when 20 centimeter cube of but1 in burns completely in 200 centimeter cube of oxygen? Okay, so the thing is that what you could do is you could figure out the moles of the individual gases and then compare it to figure out the moles of this gas. Okay, and then compare the molar ratios and figure out the volumes of each of the gas, and then what you could do is you could subtract from the total value. Okay, so this is one approach, but I on the other hand would tell you to follow this simpler approach. So whenever you have this gas, you could basically use these molar ratios. You could basically use these molar ratios to figure out their volume. The volume of this is 20, right? The volume of oxygen that is needed to react with C4H8 should be what? 20 times 6. This is what? 120. But what was the initial volume of oxygen? Was 200. So what is the volume of oxygen that was not used up? So 200 minus 120. This comes to be 80. This is the volume of oxygen that was not used up since oxygen is in excess. Now, what is the volume of this carbon dioxide that is produced? It is reacting in a ratio of 1:4. It means that 4 times 20. So this should be 80 as well. So you produce 80 centimeter cube of gas, and then 80 centimeter cube of oxygen was not used up in the reaction. So a total of 80 plus 80 should be giving you 160 centimeter cube. So the answer should be B. Okay. Now this is the working. Just a moment. So if we first of all see the molar ratios of the gas, right? For C4H8 1, for oxygen 1, and for carbon dioxide is 8. Okay. Now the thing is that I know the volume of this is 20, so this should be 20 times 6, 120, and this should be 20 times 4, 80. Now I added a total volume of 200 centimeter cube of oxygen. Now the volume of oxygen that was not used up, that remained in the reaction mixture, is going to be 80 added minus the one that was used up. Carbon dioxide produces this, so total volume that is left at the end is going to be this unreacted plus the volume of carbon dioxide that must produce 160 centimeter cube. Okay, I hope you all are clear with this question. Okay, so this was an interesting type of question. Moving on, ethanol can be oxidized by dichromate 6 ions are shown. Okay, ethanol to ethanoic acid. What is the change in oxidation number for each chromium atom? Okay, so what you're going to do is for this, you have to figure out the oxidation state of chromium, right? So 2 times x plus 7 times the oxidation state of oxygen is -2 should be equals to that overall charge of the ion, right? And from here, you should be figuring out the value of x. And what you could see is that the oxidation state of the Cr3 plus is what? Plus 3. Okay, and then you figure out the change. So it should look something like this. So for this, as I said, x, the value of x is 6, and for Cr3 plus the oxidation state is 3. Now they are saying for each chromium atom, so 6 minus 3, the difference should be 3, decreased by 3. So the answer should be C. Okay, moving on. 23 grams of ethanol is oxidized by a solution of this concentration of dichromate ions. Which expression shows the minimum volume in dm cube of the solution needed to oxidize all ethanol? So what basically you have to do is you have to figure out the volume of ethanol that reacted with this volume of this dichromate 6 that reacted with this ethanol. Okay, so what you're going to do is you first of all have to figure out the moles of this, then compare the molar ratio. They're reacting in a 3:2 ratio, should be giving you 2/3 times the moles of ethanol, right? So this should be giving you the moles of what? This should be giving you the moles of this dichromate 6. Now number of moles equals to volume times concentration. You know the number of moles and you know the concentration, so you make volume the subject and figure it out. Okay, so from here what should our answer be? So from here it should look something like this. Okay, this divided by the concentration. Now the concentration is what? 0.100. Now I have written this as 1/10. I have written this as 1/10. Now, why I have written this as 1/10? Because they haven't basically written in the format of 0.100 in nowhere in their answer. They have converted that value into 10. How they are converting it? 0.100. It means nothing but 100 divided by 1. And how many zeros are there? 3 zeros, right? How you remove the decimal? These are basically mathematics skills, okay? So yeah, this should give you the overall expression. If you reciprocal this, 10 should be coming up and 1 should be coming down. So this should be giving you the answer of this question. Okay. So this one is basically giving you the number of moles. Okay. And this is the concentration. So number of moles divided by concentration should be giving you the volume. Okay. So the answer over here should be B. I hope you all are clear with this. Okay. So this is the number of moles. This is the molar ratio. So this should give you the moles of that dichromate. You divide it by the concentration and then you figure out the volume. Now the catch was over here. You have to convert this thing into 1/10. Okay, because all of our values are given in 10. I hope you all are clear with this. If you aren't, or if you still have question or confusions with this, then do let me know in the comment section below. Okay. Question 11. A student studies a graph of rate against time for both forward and backward reactions in a reversible reaction. The student makes these statements, okay? It feels like a dynamic equilibrium question. The reaction reaches equilibrium. Yes, it does, because at one point of time, the line becomes a plateau. The forward reaction is fast initially because the concentration of reactants is at the high. The forward reaction is fast because the concentration of the reactant is high. Yeah, obviously, because as the concentration of the reactants are high and the forward reaction, the rate is going to be higher as well. If you draw the gradient, you could see that the rate of both the reactions at the equilibrium. Okay, not at all. The rate doesn't become zero. The rate of forward reaction is equal to the rate of backward reaction. This is one of the criteria for dynamic equilibrium thing, and the reaction is still happening. The reaction does not stop. So this and this should be correct, whereas this shouldn't be. So two of these statements are correct. B should be the answer. Hmm. The graph shows the change in concentration against time for a reaction. Okay. So what is the base statement for the rate? Rate is what? The gradient of this concentration time graph. Now they have given you the criteria to figure out the rate at 4. So what you're going to do is at exactly 4, you're going to draw a tangent like this. As this is an approximate, what you're then going to do is m equals to del y by del x. You have to find the gradient. You take two y values and two x values and figure this out. Okay. So this is the best approximate that I have selected from this graph, 1.2 and 0.3. And from here I have selected 6.907 and this is going to be 0.2 or something like that. Okay, so the answer is 0.134. So this is closer to 0.15. So the answer should be D. This was an estimate kind of question. Okay, so you have to take that into mind while figuring this out. So which test would not enable a chemistry student to distinguish between ethanol and ethanal, alcohol and aldehyde. Adding small piece of sodium metal, it would obviously, right? It would obviously give a positive taste with alcohol. Adding sodium carbonate, uh, warming filling solution for positive taste with aldehyde, PCl5 or OH group in alcohol, mixed fumes. So B shouldn't be the answer because there isn't any reaction for adding sodium carbonate solution to um, each of them. Yeah, there is obviously not any reaction for this. So the answer is gonna be B. Just a moment. Let me just check. Okay. So okay. Now in question 14 it says that which of the correct statements about carbon oxygen double bond found in aldehydes and ketones are correct? Okay. The C double O bond is shorter than CO bond. This is correct. CO bond consists of two pi bonds. Not at all. One is pi and one is sigma. So the first one is pi. The first one is sigma. And the second one is pi bond. Okay. And consists of four shared electrons. Yes, it does. One, two, three, four. She consists of four electrons. So which statement is correct? Exclude this. 1 and 3 should be correct. So the answer should be B. Okay. Now, which statement about this structure is correct? Okay. So first of all, what you have to do is when I get this type of questions, I always ask my students, they will, because these are gonna make the life easier for them. Label the carbon in the skeletal compounds because this kind of feels really intimidating, especially when you're in that exam condition. Okay, is 4, 5, 6, 7, 8, 9. Okay, so how many carbon do we have over here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So we have over here 9 carbon. How many carbon do we have over here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 carbon over here. And over here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So over here we have 9 carbons. Okay. So all this structure, not at all. 9, 9, 10 carbon. Structure 2 and 3 of the same compound. No, 9 and 10 carbon. Structure 1 and 3 show the same compound. Yes, it does. It has 9 over here. And how many chlorine? 1, 2, and 1. So the answer should be C. Okay, moving on. Which reaction has a standard enthalpy change equal to the standard enthalpy change of formation? So this is when 1 mole of a compound forms from its elements in standard state. 1 mole of a compound form elements in standard state. Exactly. Fluorine is gas, strontium is solid. So the answer should be this. It should be crystal clear with the definitions of enthalpy changes. Keep that in mind. A Hess cycle is shown which could be used to calculate the enthalpy change of combustion of propane. This one, okay. Or okay. Which expression is equal to the enthalpy change of X as shown in the diagram? Enthalpy change of X, right? So the arrow should be going from here to here, okay? Because from elements we are forming something, right? A compound. Okay. So this should be enthalpy of formation, right? But X is the reverse of this value, which means that there is going to be a negative value. Let me repeat. The arrow should be going from here to water, plus elements to a compound being formed. So this should be enthalpy of formation, right? So the value should, so the arrow should be like this. Since it is going in the opposite direction, this is going to be minus times 4 the enthalpy of formation of water. Why? Because 4 molecules of water are being produced. So you have to multiply that value by 4. So if you do that, your answer should be minus 4 times enthalpy of formation of water. So answer should be C. Which compound will produce a mass spectrum with a measured peak at 31? This is nothing. Take your calculator and calculate this. 17 plus 14. What is this? 17 plus 14. This is 31, exactly 31. So the answer should be A without any single thought. Okay. Now, while solving this mass spectrometry kind of question, make sure that you take your calculator and do some trial and errors. Okay. So this brings us to the end of section A. So, this is section B from the same paper. Let's just start solving this. This question is about calcium and its compounds. A sample of calcium is burned in air, forming calcium oxide. Complete the equation for this reaction, include balance symbols. So this is solid, oxygen is gas, calcium is solid, balancing. Okay, you have two oxygen over here, which means that you need two over here as well. Since you have two oxygen over here, you should be having two calcium here as well. So you should be adding two over here, and this should be the balanced equation. Now state the color change for this reaction. This is gonna be orange red. Okay, you should be having this memorized as well. The color change for this, the flame color produced during this should be orange red. Explain how a flame color is produced. So the thing is that suppose this is your electron, right? When you provide energy or when you heat it, it gains the energy, right? And as a result, as it has more energy, it basically moves to an excited or an energy level, or moves to an higher energy level, right? Or moves to an excited state. Now, when you stop giving the energy, it is not going to stay over there. What it is going to do is that it is again going to come back to its ground state over here, right? As it comes back to the ground state, it basically releases energy of a characteristic wavelength, and the energy that it releases of a characteristic wavelength or frequency gives this a characteristic flame color, gives this the color that you observe. Okay, so the energy that it emits when it falls back to the ground state gives this calcium, or you could say gives the element their characteristic flame color. Okay, so the answer for this should look like this is what I have written over here. Now what you're gonna do is just take a reading at this. Okay, this is what I have said so far. Moving on. When calcium oxide is impure, calcium oxide formed is impure because during the reaction, calcium reacts with another element in the air. So in the air, you have nitrogen, right? So it is going to lead to the formation of Ca3 into, right? And nitrogen has a charge of -3 and calcium has a charge of +2. So these, and as a result, it leads to the formation of this. Okay, so yeah, our answer over here should be this. Moving on. Another sample of impure calcium oxide made from heating limestone has a mass of this. This is the mass of the impure sample. The impurities do not react with hydrochloric acid. Okay. The sample is added to 200 centimeter cube of this concentration of HCl, forming a solution. The hydrochloric acid is in excess, which means that even after the reaction with the products, there are going to be some HCl. Okay. Now, the solution containing excess acid is then transferred into a volumetric flux and made up to 250 centimeter cube. You're basically dilating the solution up using deionized water and then mix together. What you're gonna then do is a 25 centimeter cube portion of this diluted sample is then titrated with this concentration of sodium hydroxide, a base. You're neutralizing the acid, the excess acid, okay? And the mean titer is this, which means that this is the volume of NaOH, okay? So now the question is, calculate the percentage purity of calcium oxide in the sample. So it should look something like this. Now do not get worried by seeing all of this intimidating kind of stuff. So to figure out the percentage pure, you need to have the mass of the pure sample divided by the mass of the impure sample times 100. So in the question, you were provided with the impure mass. You have to figure out the mass of the pure substance. How you're going to do that, right? So the thing is that HCl over here is used in excess. So you cannot use the moles of HCl because it is obviously in excess. You cannot use the excess of anything in your mole calculation in chemistry. However, you know the moles of this. However, you could figure out the moles of this. So okay, because you know the concentration of this and the volume of this. So you could easily figure out the mole of this. If we have the mole of this was the acid that was in excess, and this was the acid. This was the number of moles of acid that was initial. Okay, this was the moles of acid that was initially present, and you have the moles of acid that was in excess. So can you not figure out the mole of acid that reacted? So the mole of acid that reacted should be what? Initial, that was given initially, minus the excess. So initially minus the excess should be giving you the moles of acid that actually reacted. And if you have the moles of acid that actually reacted with this, you could easily figure out the moles of this using the molar ratio 2:1. And if you have the moles of this, you could easily figure out the mass of this. And if you have the mass of this, then you could easily equate into this formula and figure out the percentage purity of this sample. Now what they're doing is they're mixing the acid and the PaO together in a beaker, let's assume. And then they're basically transferring this solution to a volumetric flask. And then they are basically adding up water, 250 centimeter cube of water. They are basically diluting the solution. Then they're doing what is, from here they take 25 centimeter cube as it they take 25 centimeter cube, and they are basically titrating this up with sodium hydroxide and figuring out the moles that was in excess. And you have your initial moles. Now what you're going to do is that do do the reverse titration procedure and figure out the mass of this. Okay, so this entire process is what we refer to as reverse titration. So let's start with the moles of this. Volume times concentration. Volume was given 23.70 over here. Tighter volume, and the concentration was this. And the volume needs to be converted to DMQ. And then you have the moles of HCl because they are reacting in a 1:1 ratio. Now the thing is that this is for 25 centimeter cube. Okay, this is for this only. However, you dilated up the solution. So what was the mole? What was the mole of HCl in 250 centimeter cube? So what was the mole of HCl in 250 centimeter cube? So the mole of HCl in 250 centimeter cube would be mole times the dilution factor. So the moles in 250 centimeter cube is this. Okay. The moles in 250 centimeter cube is this. Moles times 250 divided by 25. So this gives a dilution factor of 10, you would say. So 25 times 10 should be giving you the mole of this HCl in this. Okay. Now, what was the mole of HCl that was added initially? The mole of HCl that was added initially was 200 centimeter cube and this, right? So this should be converted into TM cube. So the mole of HCl that was added initially was this, and this was the mole of HCl in 250 centimeter cube. Now what you could do is you could subtract the value of this from the initial value to figure out the number of moles that actually reacted. You have the number of moles of this now that actually reacted. You could use the molar ratio and figure out the moles of this, right? So it is reacting in a 2:1 ratio. So the mole of calcium oxide should be divided by 2. Okay. If you have the moles of it, you could easily figure out the mass of it, number of moles, mass by molar mass. You make mass the subject and you get a mass of this. You have the mass of the pure substance, also you have the mass of the impure substance. You equate this into the formula and you get a value of 90.1%. As simple as that. Okay, I hope you won't be having any more issues with this from now onwards. Okay, moving on. Calcium nitrate is a white crystalline solid that decomposes when heated strongly, with a Bunsen burner. Okay, the student suggested an explanation for this decomposition. The calcium ion is polarized by the nitrate ion. Not at all. The cation polarizes the anion, not the anion polarizing the cation. Not at all. This distorts the electron cloud around the nitrate ion, so weakens the bond between the two ions. It doesn't weaken, yeah, it distorts the bond around nitrate ion, but it doesn't weakens the bond between the two ions. So in the nitrate, there is going to be nitrogen oxygen bond, right? Now, this bond, this nitrogen oxygen bond, is going to get weakened by that polarizing cation of Ca2 plus, not this Ca2 plus and NO3 minus. Okay, not this. The Ca2 plus is going to weaken the bond in nitrogen oxygen bond in the nitrate ion. Okay, so this should be the answer and the correction. So let me just show you each of them. This is what I have written over here, right? Now what I want you to do is take a reading at this. This is exactly what I have said so far, okay? Moving on to the next question. So in question 20, it says that the question is about some reaction of haloalkanes, 1-bromopropane. Okay. So haloalkane reacting with this aqueous should be giving you alcohol, KCN nitrile, NH3 amine. Okay. Draw a mechanism with relevant lone pairs and dipoles to show the mechanism for reaction 1. Okay. So the mechanism for reaction 1 should be like this, right? This is electronegative. Halides are more electronegative than carbon, del minus, del plus. This is electron deficient, so it means electron from over here. As electron goes from here to here, this bond is going to break and this would lead to the formation of this compound and this bromide. Okay. Now, if you are having issues with this mechanism kind of thing, then I have made a crash course on the mechanism for both unit 1 and 2, which you could find in our channel. Okay. I would also be attaching a link to that mechanism video in our description box as well. Okay. Moving on. Give a reason why chemists often use reaction 2 in the formation of a nitrile when synthesizing organic compound. Okay, this is because as this reaction takes place, see, over here we have how many carbon? 1, 2, 3. But over here, see how many carbon we have over here? 1, 2, 3, 4. So the carbon number increases or the length of the carbon chain increases. Okay. So, yeah. Give the condition needed for reaction 3. So, the condition needed for reaction 3 is that NH3, okay? So heat under pressure. Heat under pressure in a closed system or in a sea tube, okay? So yeah, a different type of reaction occurs when haloalkane, this is heated with sodium hydroxide dissolved in ethanol, okay? So NaOH aqueous should be giving you alcohol, but this NaOH in ethanol should lead to the formation of an alkene, okay? Alkene. The first one that was given in the question led to the production of alcohol, but this would lead to the production of alkene. Explain why anhydrous calcium chloride is added to ethanol before it is used to dissolve the sodium hydroxide. Okay. This is a drying agent, right? So it basically removes the water that could be present in ethanol, okay? Because water have this OH minus state, okay? And this OH minus could basically act as a nucleophile as well, okay? Water could act as a nucleophile, okay? Nucleophilic substitution could take place due to this OH minus that is present in water, okay? So yeah, I have also explained about this in that mechanism video, okay? So yeah, this is what I have written. Okay, so this is it. Now, draw the skeletal formula of 3 isomer produced during this reaction. So the 3 isomer produced during this reaction, okay? So as this chlorine would be removed from here, there could be a bond, double bond formed over here or here as well, okay? There could be a bond forming over here or over here. So if you were to look at this, it should look something like this. Since chlorine is being removed from there. Now the third isomer is quite different. It should look something like this. Though similar, but the pattern kind of changes, okay? See, it was like this. And now what I did was methyl group and then this, okay? This should be the third isomer. Now these two are easy mark because as chlorine is removed from here. I bond could from over here or here. Now the third one, it was kind of tricky, okay? So yeah, moving on to the next question. Question 21. This question is about group 7 elements and their compounds. The compound NaClO3 is used in paper to bleach wood pulp, okay? It is made by the reaction of hot sodium hydroxide solution with chlorine gas, okay? Explain in terms of oxidation number, what type of reaction is this? Chlorine 0 over here, chlorine is -1. over here chlorine is +5. What I could see is that from 0 to -1 and 0 to +5. This is a disproportionation reaction since both oxidation and reactions are occurring, okay? So yeah, this is what I have said over here. Just take a reading at it. Okay, moving on. What is the percentage atom economy by mass of NaClO3? The formula of atom economy is MR of desired product divided by total MR of all product times 100. Okay, so this is the formula and this is the value of 23.5%. Okay, now while calculating this, you have to take into account all of these numbers present over here as well. Okay, so yeah, moving on. Now this question says that a student test tests samples of solid sodium chloride and sodium iodide with concentrated sulfuric acid. Okay, the observations are made. So first of all, what you have to know is that halides, they are reducing agent, which means that they reduces other substances. They decreases the oxidation state of other substances. Okay, halides are basically reducing agents, and they does what is they decreases the oxidation state of other substances. So suppose if something is +5, they can make it +4 or +3 or something like that. Okay, so that's what I've said. They act as reducing agent. They reduces the sulfur in H2SO4. They decreases the value of this sulfur. They decreases the oxidation state of this sulfur. Okay, now, down the group, the reducing ability increases, which means that they could further decrease the value of sulfur. So, suppose as the reducing ability increases, they could change the sulfur to -2 as well, right? So, they could, what they does is basically they decreases the, as the reducing ability increases, they could decrease the positive value of the sulfur to extremely negative values. So down the group, the reducing ability of the halides increases. Okay. With sodium chloride misty fume, HCl is formed smoke. Okay. Sodium iodide misty fume, HCl is HI is formed, and then there is this purple vapor iodine form and smell of rotten egg. This is gonna be for H2S. Okay. Egg, rotten, the disgusting smell. Now, evaluate these observations to decide which halide is a stronger reducing agent. Support your answer with the products form and the observation, oxidation state changes, deduction, which is the stronger reducing agent, an ionic equation that produces the smell of rotten egg, H2S. Okay. Now, now the thing is that, okay, understood. Okay. So now the thing is that let's just take a look at the answer that I've written for this. This is the overall answer of this. The iodide is going to be the stronger reducing agent. Misty fumes is going to be due to HX, HCl in NaCl and HI in NaI. NaI has extra observation, purple color, iodine forms, as I said. Rotten egg smell, H2S forms. This means that NaI, in the NaI reaction, iodide is oxidized from -1 in iodide to 0 in iodine. Why 0 in iodine? Because this is neutral element, and since iodine is being formed, the oxidation state of iodine is going to be 0. So it changes from -1 to 0. Okay, -1 to 0. How does it change from -1 to 0? It basically is losing the electron to something else. Okay, it basically is losing the negative charge. It basically is losing the electron to something else, and hence this oxidation state decreases in iodine. So iodide must be acting as a reducing agent. At the same time, sulfur is reduced from +6 to -2 in H2S. +6 to -2, it meant that it gained electron, sulfur. Why did the electron come from? From the iodide. And with NaCl, there is no change in oxidation state, obviously. it stays -1 in Cl and HCl. So chloride does not reduce sulfuric acid as strongly as iodide does. So Cl minus is a weaker reducing agent, and the ionic equation should look something like this. Now, if I were to show you the reaction for this, it should be looking something like this. Now, as a chemistry student, you shouldn't be having this memorized. You should be deriving this, right? You should be deriving this. Now, I will not be going into these details of this overall procedure in this video. I do have another video where I have showed you how to derive these redox equations. I will be attaching the link to that video in the description section as well. Okay, moving on. So, question 22. In question 22, it says that the Sabatier process uses carbon dioxide and hydrogen to produce methane and water. Okay. The delta H is this, which means that the forward reaction is exo. Thus, this represents the direction of forward reaction, so backward reaction is endo. The process is carried out at temperature 400 and a pressure of this, in the presence of a nickel catalyst. Describe the advantage and disadvantage of using such high temperature and pressure. Okay, so as high temperature, as you use high temperature, it increases the rate of reaction because particles have more kinetic energy, and as a result, there are more successful and frequent collision. And also, as pressure is higher or as high pressure, right? Pressure is inversely proportional to volume. So as pressure increases, volume is gonna decrease, which leads to increased frequency of collision. Or you could say that there are more gas particles per unit volume since the volume decreases with increasing pressure. Now, as the pressure increases, equilibrium shifts to the right. Why? Because there are 3 moles of gas to the right. On the other hand, there are 5 moles of gas to the left, right? So equilibrium shifts to the right. So that increases the yield of the product. However, as the temperature increases, equilibrium should shift to the left. Why? Because the backward reaction is endothermic, which decreases the yield of the product as well. Now, as you use higher temperature, it is going to increase the overall cost of the procession. Okay, it is going to make it costly. And also, if you use higher pressure, you basically need to have stronger equipments that could like withstand that high pressure. So it is obviously going to increase the cost as well. Okay, so that's just what I've written over here. Take a reading at all of the points. So once you're done with this, let's just move on to the next question. State how a catalyst increases the rate of reaction. So it basically provides an alternate route that reduces the activation energy or that reduces the EA. Okay, you could write EA or activation energy. So that brings us to the end of section B of this paper, everyone. Okay, this is section C, the last part from this paper. Okay, so let's just solve this. This question is about alcohols and related compounds, propan-2-ol, which is a secondary alcohol. Why is this a secondary alcohol? Propan. Propan-2-ol. The OH is joined to a carbon that is joined to 2 other carbons, okay? And hence this is a secondary alcohol. One of its uses is used as a solvent to clean wine decodes, okay? So there was this old musical apparatus like this. Okay, so this is what we refer to as this. Propan-2-ol can be also oxidized to form ketone. Since this is a secondary alcohol, it could lead to the formation of propanol. However, most of the propanol produced in industry is made using cumene, where hydrocarbons from oil are used to synthesize cumenes. Okay, and this benzene plus propane leads to the formation of this cumene. Cumene is then oxidized directly to form phenol and propanol. Okay, phenol, this is and propanol. Now, do not confuse yourself with all of this because you do not have it in your syllabus. Benzene and phenol is for the A2 spec. Okay, but yeah, just take a look at it. Okay, do not confuse anything up. Just that propane and phenol is formed. They don't even look at the structure. They're basically trying to trick your brain. They're trying to intimidate you with these skeletal structures that you have never seen in your life. Propanol is a solvent that is used as a fuel. The fuel biopropanol is mainly propanol that is formed from glycerol, a waste product of biodiesel production from plant oils. Okay, the reaction used is called hydrogenolysis and requires catalyst containing this. Okay, understood. Now, state what is meant by the term secondary alcohol. I have already shown you and explained what does this mean in the above part. Okay, so this is it. The oxidizing agent used to oxidize propanol in a laboratory is acidified solution of dichromate 6. The reaction mixture is placed in a pear-shaped flask and heated for 30 minutes. Okay. Give the name of the additional piece of equipment needed when heating the reaction mixture for this length of time. This is going to be a reflux condenser or a Liebig condenser, right? Do not say heat under reflux. That is the procedure. They have asked you for the apparatus. And the color change that occurs during this reaction is going to be dichromate 6 to 3 plus, right? This is green, this is orange to green. Moving on. Describe how IR of the reaction mixture would change during this reaction. You should consider only the organic reactant and the product, and you could basically have to use information from data booklet to support your answer. So first of all, this OH is getting converted to ketone. So the peak that this OH in alcohol that is approximately at 3400 centimeter to the power minus 1 is obviously going to disappear. And a peak at this range for carbonyl ketone is going to appear. This is around 720 centimeter to the power minus 1. And also, OH has a fingerprint region, right? And ketone, on the other hand, has a fingerprint region. So the two fingerprint region are not going to be the same. Since these are going to be different compounds, the fingerprint region is going to change as well. Okay. So, yeah, that's just what I have written over here. Just take a reading into it. Okay, so let me just remove this thing. This is kind of redundant at this one. We don't even need to write this down. Okay. So, yeah, that's it. This is what I have written over here. So I'm not going to the data booklet, okay, at this one. The cumin process is shown using the molecular formula. Benzene, propene, cumin, oxygen, liquefied phenol, and propanol. Calculate the mass of benzene in kilogram needed to produce 200 dm cube of propanol in the cumin process. You could assume that the overall yield of the 85. Okay. First of all, figure out the mole of this uh, propanol. If you have the mole of this propanol, you could figure out the mole of this. Compare the molar ratio. If you have the mole of this, see, you have cumin over here, you have cumin over here. If you have the mole of this, then again compare the molar ratio with benzene. And if you compare the molar ratio with benzene, number of moles mass by molar mass, you would have this, you could easily figure out the mass. Now, one thing you have to take in mind is that 85% yield thing, okay? So, the overall process would look something like this. You have been provided with the volume of propanol and density. So we know that density mass by volume, you have density, you have volume, you could easily figure out the mass of propanol. If you have the mass of propanol, you could easily figure out the mole mass by molar mass. What do you know is that percentage yield equals to actual by theory times 100. Now, you have the theory you have found over here. You know the percentage yield value 85%. You do not know the theory, however, you have to figure the theory out, and that is times 100. So the theory is gonna be this, okay? The theoretical mole, you could say. Theoretical mole, okay? The theoretical mole should be this, 85% yield. If this is the mole, theoretical mole of this, if this is the theoretical mole, then the mole of cumin is gonna be this, and the mole of benzene is gonna be the same as well because they're reacting in a 1:1 ratio. Then what you could do is, you know the number of moles, you know the MR, you could easily figure out the mass. Now, once you have the mass, this is in grams, you have to divide it by 1000, convert it into kilogram, and this should give you the answer of this question. Easy enough, okay? Moving on. Most chemists would say that step 2 of cumene process has an overall percentage atom economy that is 100%. Even though there are two products. Oh, yeah, oh yes, because there's this phenol and there's this propanol, okay? So they're saying that they have an atom economy of 1. So why is this? This is because phenol has a market value. Phenol can be sold as well. So there isn't any redundant or any waste product being produced. There is an economic value for phenol as well, okay? Moving on. Now, data about some physical properties of propan-2-ol and propan-1-on are shown. Compare and contrast the physical properties. You should refer to intermolecular forces. Okay. Now, propan-2-ol has a higher boiling temperature than propan-1-on. Why? Because propan-2-ol has an OH group, right? Oxygen attached to hydrogen, which means that it could form hydrogen bonds between the molecules. And hydrogen bonds is one of the strongest intermolecular force of attraction. Propan-1-on, it has this, right? So it cannot form hydrogen bond between the molecule. It can only form London dispersion force and permanent dipole-dipole interaction. Okay, because this oxygen is del minus and this is, so it could form dipole-dipole interaction and London forces. These on the other hand could form hydrogen bonds as well. The both are miscible, which means that they both can form hydrogen bonds with water, and this can form self hydrogen bonds. This can form hydrogen bonds with water, but between itself, between the molecules of it, between the self molecules, it cannot form hydrogen bonds. Okay, so yeah, that's just what I have written over here so far. Just take a reading at it. Okay, so I hope you are clear with this. If you are, then let's just move on to the next question. The thing is that I do not even read this type of questions because I know what is coming. Okay, so what I tell my student is that this as a unit of what? Kilojoule per mole. Okay. So del H was to minus kilojoule per mole. What does this mean? AMC del T. Because this is coming from Q, energy. And this is the mole of the substance that we are interested in. But again, let's just read the question. A copper calorimeter containing this volume of water, this is our mass of water, and this temperature was heated using a spirit burner. Okay. A mass of this of biopropanol is burned during this experiment. Calculate the maximum temperature of the water at the end of the reaction. You should assume that there is complete combustion and that all of the energy is transferred to the water. Okay, this is a really important point. Since they have stated this, it made our work way more easier. We know that del C combustion is this. Okay, so what we are going to do over here is that see del C is minus kilojoule per mole. Kilojoule is what? Q. Q is what? MC del T. This is energy divided by N. Now you know the mass of water 200. You know this 4.18 given in the question. You have to figure out del T. Del T is what? Final minus initial. Okay. What you're going to do is you have to make final the subject. Final. Final is del T plus initial temperature. You have to figure out the value of del T because you have the initial temperature that was 20 degrees Celsius. That's so you could figure out the maximum temperature. And the N is for biopropanol, mole of it. 200, this, and mole 1.02 and propanol, right? 1, 2, 3. 3 hydrogen, sorry, 3 carbon, 1, 2, 3, 4, 5, 6, 7 hydrogen plus 70. This should be the MR. Now the thing is that the answer that you would get over here should be in joules. But del CH, see, delta H is in kilojoules. So you should be dividing this answer by 1000. And you make del T the subject. If you make del T the subject, you will resolve this equation and make del T the subject. If you make del T the subject, you would get a value of this. Now, as I said, del T final minus initial, you have initial of 20. This was given in the question. See, easy question. So you make final the subject, and it would lead to this plus this. It would lead to a value of 61 plus 6 degrees Celsius. I hope you all are clear with this. Okay, moving on. Biopropanol has a higher octane number than bioethanol. Name the process carried out on alkane obtained from crude oil to increase octane number, carbon number, or octane rating, you could say. Reforming process. Okay. So yeah, everyone, this was the end of our entire paper. All the best for your unit 2 exam. Have a great day and thank you. If you found our video to be helpful, then make sure to like, comment and subscribe. We'll be posting the video on October 2025 unit 3 as well.